4.7, graph linear functions. So this title may sound a little bit familiar. We did graph linear equations previously. Okay, which the good news is, as far as graphing goes, there's really no difference in what we're doing. It's just the notation that we have it in is different. So function notation would be f of x equals mx plus b. So the difference is when we're in our normal notation that we have y equals mx plus b. What's the difference?
F of x equals mx plus b.
Yep. So f of x versus y, guess what? They mean the exact same thing. F of x is the same as y. It's a different way to write things that's going to tell us some other things about our particular function. Okay. A lot of times they get used interchangeably. It just kind of depends on the situation. But f of x will be the notation that you have pretty much for the entire rest of your math career. It doesn't have to be f. It can be g of x, p of x, t of x. It does not matter. It's just a notation. Okay, this says that this is a function of x. So basically it's just saying x is the variable that's causing the function to change. So let's see. Looking to see what other definition things we need. Nope, if I can click the right button. All right. A family of functions is a group of functions with similar characteristics So, for example, f of x equals mx plus b constitutes a family of linear functions. Okay, because we don't know what each of those things is equivalent to. Like, what does m equal? What does b equal? So that would just be a family of linear functions right there. Parent function for linear functions. So this is going to be kind of the first parent function that you see. Later on in the year, we will see the parent function for quadratic equations. And then as you continue on in math, you'll see in pre-cal we do 12 basic functions. Okay, so now that's a while away. That's junior year. But we do parent functions for 12 basic functions. So there's a lot more, but this is the parent function for a linear function. So for a line, so the most basic linear function in the family of all linear functions called the parent linear function is f of x equals x. Okay, so that just tells us that this is going through the origin, okay, because it has a y-intercept of 0 and a slope of 1, so it goes up 1 over 1 or down 1 back 1. And so the graph of this would be something like this. So we would have Intercept at 0. Slope is up 1 over 1. Or down 1, back 1. Nope. Okay, close enough. So this would be the graph of the most basic parent function. All right, so the real new stuff that we're doing in this section is evaluating a function for different values of x. Okay, and then if we're given a function, solving for x based on what the function is supposed to be equal to. So these first ones say to, and this is going to be for all of these, evaluate the function when x equals -2, 0, and 3. So essentially we're going to be doing these problems 3 times. So every problem is going to have 3 answers to it. Okay? So number 4, g of x equals -3x plus 5. So they want us to find the value of this function when x equals each of these things. So I'm going to have 3 separate functions. So the way that we do this in correct notation is we say g of, and we replace x with one of these numbers. So we're going to do them in order. So g of -2. And what this tells me to do is that any x that I have in my equation, I'm going to plug in a -2. Okay, so if there's multiple x's, everywhere I see an x, I'm plugging a -2. In our situation, we only have 1, so it's only getting plugged in once, but if it was in there 100 times, we'd plug it in 100 times, okay? So this is -3 times, we replace this x with this number, so -2 plus 5. What's -3 times -2? 6 plus 5 is 11. Okay, so your answer for the first one would be 11. So g of -2 is equal to 11. Okay, then we have g of, the next value they want us to do is 0. So anywhere I see an x, I'm going to put a 0. So -3 times 0 plus 5. What is -3 times 0?
0.
Plus 5? And if you wanted to write 0 plus 5 and then just write that it's equal to 5, that's also fine. So the big things that I'm going to be looking for in these problems is that you're showing me what you're plugging in. So g of whatever, or whatever letter they use all different letters in this particular section of problems. And then I want you to show me actually plugging it in, and then you can go straight to an answer once you've shown what you're plugging in. Okay? Now, remember, the more work you show, the more credit I can give if you have the wrong answer. So just keep that in mind. All right, the last one we need to do is g of 3. So g of 3. So that means anywhere I have an x in the equation, I'm going to plug in 3. So this is -3 times 3 plus 5. -3 times 3 is? Plus 5 is? Yep, so -9 plus 5 equals -4. Easy enough, right? Just plugging in. All right, let's do another one. So we're going to, for all of these problems in this, we're plugging in -2, 0, and 3 for this batch of problems. Number 6, h of x. So notice they're using h this time. Doesn't change anything about the problem, just a different letter. H of x equals 2.25 times x. So first one I'm plugging in is -2. So in this case, I have h of -2. And anywhere I have an x, I'm going to put a negative 2. So 2.25 times negative 2. Now, there may not be a number that you know right off the top of your head, but I do know because I have a positive times a negative that this is going to be negative. So then if you want to off to the side, do 2.25 times 2 this way so that you can work it out. 2 times 5 is 10, carry the 1. 2 times 2 is 4, plus 1 is 5. And then 2 times 2 is 4. We have 2 decimal places here, so I need to shift it over. So this would be negative 4.5. If you want to put the 0 on there, you can. You don't have to. All right, the next one is plugging in 0. So h of 0 equals, we're putting in 0 for x, so 2.25 times 0 is what? 0. And lastly, we're plugging in 3, so h of 3 equals 2.25 times 3. So again, if you want to do that off to the side, you can. So 3 times 5 is 15, carry the 1. 3 times 2 is 6, plus 1 is 7. Then 3 times 2 is 6. I have 2 decimal places, so I need to move this over 2. So 6.75 would be the answer for this one. So hopefully this looks kind of familiar, okay, because we've done stuff where we've been plugging in for x before. We haven't had to do it necessarily 3 times for a particular problem. In a sense, we have done this before, but it's a little different. And then the only real difference is just the notation, that we're showing what's getting plugged into the function for x versus how we were just plugging in a number before. So, but this is just a better notation because it makes it very clear exactly what you're doing every single time. Let's jump down to number 10. D of x equals negative 3 over 2 times x plus 5. So negative 2 is getting plugged in first. So d of negative 2 equals, I've got negative 3 over 2 times negative 2. If you want, since that's a fraction, to put it over 1 to help you to visualize it, you can do that. Plus 5. What happens here with this first piece?
They cancel out. The 2s.
Yep, the 2's cancel. The thing to remember is this was negative, so this has to be a negative 1 essentially left here now. If you need to write it over top, you can. So negative 3 times negative 1 is?
1.
No, it'd be 3.
Positive 3 plus 5 is? 8. Now if we do 0, so d of 0 equals negative 3 halves times 0 plus 5. What do I get when I do that? 5. Anything times 0, 0. And lastly, they do 3. This one's a little harder. So d of 3 equals negative 3 over 2 times 3. If you want to put it over 1 to make your visual a little bit easier, you can. Plus 5. What's negative 3 over 2 times 3? Negative 9 over 2 plus 5. What do I need to do to be able to add these things together?
Have a common denominator.
How do I get a common denominator?
Multiply 5 by 2.
Yep, multiply this by 2 over 2. So I get, move down here. So, yep, negative 9 over 2 plus 10 over 2. And when I do that, what do I get? 1/2. So the answer to that one would be 1/2. All right, any questions on those where we're plugging stuff in?
No.
All right. So notice the instructions on these ones said evaluate the function when x equals negative 2, 0, and 3. Okay, so we were solving the function when given x values. Now we're going to be doing the opposite. Okay, so now what they are going to do is they say to find the value of x so that the function has the given value. So they're going to give you a function, and then they're going to do like a semicolon, and they're going to give you a number. Okay, that number is what the whole function is equal to. So number 14, f of x equals 6x plus 9. And they say that it's like a semicolon and then 3. Okay, so I'm solving for x. Okay, that means that f of x is equal to 3. Okay, so in these problems, think about it as y is equal to whatever is given. So this problem would be 3 equals 6x plus 9, and now you need to solve and get x by itself. So how would I do that? Subtract 9, so I would have over here 6x equals 3 minus 9 is negative 6. Now what? Divide by 6. What's negative 6 divided by 6? Negative 1, so negative 1 equals x. If you want to flip it, that's fine too. It does not matter. All right, 16. H of x equals negative 7x plus 12, and it is equal to negative 9 is what they tell us. So if you want to put the negative 9 on the left side like I did with the 3 on the previous one, you can do that. But guess what? I can also put it on the right side. If you like your variable on the left, you can do that too. I'm going to do that with this one just so that we see that it doesn't matter. Negative 7x plus 12 equals negative 9. So if you like that notation better, you can do that. If you want the first one, so you keep everything exactly where it goes, that's also fine. How do I solve this?
You subtract 12.
Subtract 12, so I have negative 7x equals negative 21. And what do I get when I do that? X equals 3. Let's see, 18. M of x equals 9x minus 5. And they tell us that m of x is negative 2. All right, how do I set it up? And I don't care which way you do it.
And 9 equals 9x minus 5 too.
Negative 2 equals 9x minus 5. If you want to do it the other way and say 9x minus 5 equals negative 2, you're going to get the exact same thing. I do not care which order you write it in, as long as you get to the right final answer. Don't care. All right, what do I do?
You add 5.
Add 5, so I have 3 equals 9x. Then what?
Divide by 9.
So I have 3 over 9 equals x. Am I done?
No.
What do I need to do then?
Simplify.
And what do I get when I do that?
1 over 3 equals x.
1 over 3 equals x. Let's see. We okay on these ones?
Yeah.
So, I know y'all are saying, well, this stuff's really easy. It's meant to be easy, okay? Because why we did everything the way that we did in chapter 3 or whenever that was. I think it was chapter 3. All runs together now, right? But the key part here is you've got to make sure you pay attention to the instructions to know if you're plugging in for x or you're solving for x, okay? So I use the same instructions when I write quizzes and tests, so keep that in mind. But make sure you're paying attention to instructions as you're working them so that you know when you get to the test, okay, what am I actually doing here on these problems? Because that's like probably the biggest thing is people don't follow instructions, okay? The last stuff in this section is graphing the functions, okay? I know that for the most part, y'all are doing pretty well with graphing with the intercept and the slope, okay? I checked all of your graphs, and some of you have a little bit of disconnect somewhere, which I kind of think I know where it is, but some of you, it's kind of hard to tell where it is. So I'm going to do a few of these. They're not going to be any different than the way that we have done other problems, okay? So these ones are just graphing the function. So instead of graph the equation, now it says graph the function, okay? Is there something outside?
I don't know, he keeps looking up there. He said something weird. Yeah.
I don't know. Okay.
What are you looking at?
24. H of x equals 6 plus x. All right, and our goal is to graph, okay? In general, ignore what's written here. What equation, or like what form do I need to be in to be able to graph the equation?
We did this.
N equals y2 minus y1 over x2 minus x1.
That's the formula for slope. What'd you say, Jonathan?
I said y equals mx plus b.
Yep, y equals mx plus b, okay? Is this in that order?
No.
No. Now, it does not matter. Both pieces are still there, but for the sake of us being used to it in the same form, I would rewrite this as h of x equals x plus 6. It means the exact same thing, but that way you don't get mixed up with what's m and what's b, okay? Now, people tend to get thrown off when they see h of x instead of y, but they mean the same thing, so we don't do anything differently when we are graphing this, okay? So, what is my slope?
1.
1. What is my y-intercept? 6. All right, so I'm going to set up a graph over here. All right, so first thing I do is I plot this y-intercept. That means at that point it's getting plotted on the y-axis. Okay, I know y'all know this, but I'm doing it as review based on what I saw on our worksheets. So I plot that point on the axis. So 1, 2, 3, 4, 5, 6, and I put the point right there. The slope of 1 tells me I'm going up 1 and right 1. So up 1, right 1. Or, okay, I don't want to make my graph any bigger going that direction, so perhaps I want to go backwards, or on that worksheet there were a couple that you needed to go backwards, and that also seemed to be where a little bit of our issues were. So the other thing that I can do is I can go down 1 and back 1, because when I go to connect my lines, that still gives me a positive slope. Some of you had very curvy lines on your worksheet, which tells me that you were not paying attention to how you were graphing, okay? And I'm not talking like, oh, you accidentally like put a little curve in your line. I'm talking like some of your points were doing stuff like this, okay? So it should make a line, okay? If you took a piece of paper and you lined it up and you drew it, okay, it should be making approximately a straight line. Now, if you have something like this, I understand it happens. Believe me, when I freehand, it is not as pretty as my iPad. That's okay. But you shouldn't have points doing things like this or whatever, okay? It's like basically the same problem. Okay, 28. T of x equals x minus 3. So, what is my slope?
1.
What's my y-intercept?
-3.
So, I'm going to set this up. Intercept is at -3, so on the y-axis, I'm going down to -3. Slope is 1, so that means up 1, right 1. And I can keep doing that up 1, right 1 if I wanted to keep going. Whoa, that was about to be really bad. Now, obviously, if you don't have graph lines, your dots are not going to be on here perfectly. If you have graph lines, that's fantastic, but I'm not putting them on for just graphing a couple points, okay? Which obviously in your homework can be a little bit of an issue. On the worksheet, that should not have been the problem because there were little graph cubes for you to graph on. 32. K of x equals negative 6x. What's my slope?
One.
Slope is negative 6. Always the number in front of x. What is my y-intercept?
0.
0. There's nothing plus or minus over here. We know it has to be 0, just like the direct variation ones we were doing yesterday. Okay. So I set this up. Alright, so I have an intercept of 0. So that actually is at the origin. So it's 0, 0 right there. Now, this is a slope of negative 6. Okay, that means I have to go down first, then to the right, because I want something going like that. So, down 1, 2, 3, 4, 5, 6, and right 1. Or, okay, because that could be an excessively large graph, I can also go up 6 and back 1. So up 1, 2, 3, 4, 5, 6, back 1. And then I can connect my dots like that. And so that one is very steep, but it's still going down, okay? I would recommend that you always do your first slope point going the direction that it should be. So what I mean by that is do the down 6, right 1 first, because then you can make sure that your other point that you're putting on, if you decide to go the other way, makes sense. Okay, because I think that's also where some issues were, is people doing it the opposite way from like what it should have been first. One more, just to make sure that we're good on graphing, to hit some different stuff. M of x equals negative 7 over 2 x. What's my slope?
Negative 7.
Negative 7 over 2. What's my intercept?
0.
So, set up my graph. Going to need to be a little bit bigger on the y because the negative 7 over 2 tells me I'm going to be going down 7 or potentially up 7, depending on how we decide to graph it. All right, so I have that intercept at 0. Slope of negative 7 over 2 tells me to go down 7, right 2. So 1, 2, 3, 4, 5, 6, 7. Right 1, 2. Or if I want to not make my graph so big, I can go up 7, back 2. So 1, 2, 3, 4, 5, 6, 7. Back 1, 2. And connect it. And there it is. Any questions about any of this stuff? I know it's kind of review, but also a little bit new, so I'm going to give you your problems, and then I'm going to hand back your worksheets to you. Let's see. 3, 5, 11, 15, 17, 21, and then graphing, let's do 25, 27, 31, and 33.